We are in Open Campus Math 099, and we are now in Module 17, which is solving quadratic equations. Today, we're going to learn a different method to solve a quadratic equation. If you recall, a quadratic equation is an equation that has an x squared in it. And because it has an x squared, that means we're going to get two solutions. We learned the other previous week to solve a quadratic equation, you set it equal to 0 and factor it. But we're going to see how today factoring doesn't always work. So in Module 17, we're going to learn how to do the square root method to solve a quadratic equation. Let's look at our notes for a minute. If you remember, a square root symbol we saw in Chapter 15. And square rooting is the opposite or inverse of squaring a number. So if I wrote 3 squared is 9, then I could do the opposite and square root that answer 9 and get back to 3. So because quadratic equations have an x squared in them, then to get it to become an x squared to an x, we're going to do the opposite. And the opposite of squaring is a square root. All right, let's go to the whiteboard. Just to recall from the previous lesson, this is an equation because it has an equal sign. It is quadratic because it has an x squared. We said last time to solve a quadratic equation, you want to set it equal to 0 and use your factoring skills. But to factor, you have to use one of your 3 rules. Either do GCF, difference of perfect squares, or trinomial. So if you look here, if I want to factor x squared minus 9, is there a greatest common factor? No. You cannot divide x squared and 9 by the same thing. Is it a difference of perfect squares? Well, yes, it is. It's a difference, and x squared and 9 are perfect squares. So we would factor this. We'd put 2 parentheses. What times itself is x squared? X. What times itself is 9? 3. To multiply to get a negative, you have to 1 positive, 1 negative. We said the previous lesson in Module 16, when you factor a quadratic equation, you now make 2 x's. But they're no longer quadratic. They're x to the first, they're linear. So now we write 2 linear equations by setting them each equal to 0, and we solve. And just like in Module 16, when you solve a quadratic, you will always get 2 solutions. Now, here is today's problem. This is the quadratic equation I want you to solve. X squared minus 8 equals 0. Again, we know it's quadratic. It has an x squared. It's already set equal to 0. So all I'm asking you to do is, can you factor it? Well, do we have a GCF? No. Cannot divide a letter, a variable, and a number by the same thing. Is it a difference of perfect squares? No, it's not. Even though it has a different sign, we've already learned in Chapter 15, 8 is not a perfect square. So you cannot factor this equation and make the 2 parentheses to get it linear. So I know what you're thinking. You're saying, well, we just don't solve it. No, every equation can be solved. We just need a different method today to solve this quadratic. And today's method is doing the square root. Now, what you have to learn is a different procedure. What are the steps to solve doing the square root method? Step 1 is you do not want the equation equal to 0. Because, guys, the square root of 0 is always going to be 0. So to solve this by doing the square root method, step 1 is to move your constants to the right. You want to move every number away from the square root that you possibly can. So we already know how to do that. So I'm going to move this negative 8. How do I move a negative 8? I do the opposite. I add 8. That's going to cancel. So we bring down our x squared, and 0 plus 8 is 8. Once everybody gets moved, step 2 is now to square root. But because this is an equation and it's got a balance, you have to square root both sides. So, we're going to square root the left side. We're going to square root the right side. What have we already learned from chapter 15 about squares and square roots? Well, they undo each other. What times itself is x squared? X. You can think of this exponent and this root symbol just like you think of adding and subtracting 8. When you add 8 and subtract 8, it cancels out because they're inverses, they're opposites. The same thing. This square and this square root are going opposite, so you can cancel them out. Now, on the right side, we have a square root of 8. Well, from our previous lessons, is that a perfect square? No. But what perfect square is in 8? And that's always the third step. After you square root both sides, the third step is then to reduce your root. We have to have our answer in simplest form. So, we have to use what we learned in the previous chapter and say, okay, I have x equals. I know in 8, there's the perfect square 4. So this is 4 times 2. And we've already discussed this in chapter 15. What is the square root of 4? Oh, that's a 2. So the 2 comes out. Can you square root the number 2? No. So it stays inside. Now, here's our last problem. We said the last lesson in module 16, when solving quadratics, this exponent 2 means how many solutions? A quadratic always has 2 solutions. So the question is, there's only one answer here. Where's the other answer? And this is something you're just going to have to memorize. If we go back to this step right here, when you do the square root of 8, this symbol means in words, what times itself is 8? Well, let's think about an easier number. For example, if I asked you all, what is the square root of 25? That means I'm asking you, what number times itself is 25? And I know you first would say 5, and you're correct. 5 times 5 is 25. So you're right. The square root of 25 is 5. But isn't there another number times itself that makes 25? Yes, it's negative 5. Negative 5 times negative 5 is also 25. So technically speaking, every time you square root, you should have 2 solutions. And that's the step we're going to have to put right in here. When you square root those 2 sides, you have to show 2 solutions. And the way you show that is you put a plus or a minus. So when you come over here and you say you're going to square root 8, you're saying one of the answers is going to be positive and one of the answers is going to be negative. And then you just bring this symbol down the whole time. You do not put this plus or minus at the end when you're done. You put it physically when you're square rooting. The reason why we don't put it on the left side is because, look, is there a square root here? No. Now you're probably thinking, but wait a minute. When we were doing chapter 15 on roots, we didn't ever put a sign. Well, in math, there's a difference between writing this and saying it. If I write down square root of 25, it is understood you only give the positive answer. That's why in chapter 15 you just wrote 5. But if you look, was this square root symbol in the original equation? No. So the rule of thumb is when you put a square root symbol in the equation, it's like you saying in words, what times itself. And if I said in words, what number times itself is 25, you'd either have to say 5 times 5, or you could say negative 5 times 5. So the only trick to doing the square root method is remembering on the right side, when you put the square root symbol, to put the plus and minus in front to make sure you have 2 answers. Alrighty, that's the procedure. So you have to memorize. To solve a quadratic by the square root method, first of all, we would only do this if our equation would not factor. Secondly, what are the steps? Move the constants, the numbers to the right, square root both sides, make sure to show two answers. You put the plus or minus on the right, and then make sure you always reduce your root. Okay, another way to write this answer would be to write it separately as 2 square root of 2 and negative 2 square root of 2. As the plus and minus means, there's two solutions. And yes, if you took out your calculator and typed that in, you would get a decimal. You would get a decimal, but the decimals would go on forever and ever. Those are irrational numbers. We've already discussed that. And we do not want those decimals as answers. We'd rather keep it in radical root form. All right, so now let's go back to our notes. So now let's look at equation 2 in your notes. I want to solve 2x squared minus 32 equals 0. And I do not want to factor this one. Again, I want to make sure you all understand the square root method. So let's go to the board and see if we can walk through the process. Okay, so step 1 says move the constants to the right. So we're going to move a negative 32 by adding. So that's going to give us 2x squared equals 32. But are we done moving all the constants, the numbers? No, we're not. This 2 is connected by multiplication, so we can move it by division. And you must move everything over that you possibly can. 2 divided by 2 cancels. That leaves us x squared. 32 divided by 2 is 16. Now we're ready to do the square root. So the moral of the story is on the left side, you want the term that's being squared. On the right side, you want your numbers. Now you're ready to square root both sides. What do squares and square roots do? Because they're opposites or inverses, they cancel out. And that leaves us with just good old x equals, as soon as you get to the right side, because you squared root, to have two answers always, you need to put your plus and minus symbol. Now, are we going to accept the square root of 16? No. We know 16 is a perfect square, so what number times itself is 16? 4. There's no work to do there. We know that. If you look, you have two solutions. X equals 4, x equals negative 4. You could write it separately, or you could write it with the plus and minus together. But either way, every time you solve a quadratic, you must have two solutions. Remember from the previous module, you must show all this work. You cannot solve equations in your brain. You have to show step-by-step procedure. Okay, let's go and try another one out of our notes. Let's look at example 4. So example 4 in our notes says x plus 6 squared equals 49. Okay, first step is to move the constants to the right. So I'm going to ask you, can you take that 6 and move it here? No, you cannot, because that 6 is stuck in parentheses. So we can't move anything right now, because it's stuck in parentheses. So guys, this is real simple. To get rid of this parentheses, we'd have to get rid of this square. What's the opposite of squaring? Correct. It's square root. So there's no rule that says you have to move a number first and then square root. Because we can't move anything yet, let's get the square root done first. Squares and square roots are opposites. They're inverses. So what they do is cancel, just like add and subtract cancel. That would leave us with x plus 6. Do I need to keep that in parentheses as it's all by itself on the left side? No. So let's drop those parentheses. Equals, what are we going to put here? Plus or minus. Now I have square root 49. Now, all roots have to be reduced. X plus 6 equals plus or minus. Do we have any work here? No. 49 is a perfect square. What times itself is 49? 7. But you're not done. Remember, your goal in solving equations is to find out what x is. Get it isolated by itself. So we're still going to have to move that 6. But you don't want to move that 6 right now because we can't work with both a positive 7 and a negative 7 at the same time. So what you need to really do is write two equations. X plus 6 equals positive 7. X plus 6 equals negative 7. That's what that statement says. It equals both the positive and a negative. So if you write it as two equations, now you can move the 6 and get your solutions. X is 1, and negative 7 minus 6 is negative 13. And when you write these, you could separate them with a comma. Whatever you do, do not put them in parentheses. Because if you remember, if you put an answer in parentheses, then you're saying that that's an ordered pair of points. And a point has an x and a y value. And we did not find x and y. We just found two different answers for x. Okay? So the moral of the story is, every time you solve a quadratic, you have to get two solutions. We could check these. They'll both work. But if we talked about this, to check, you go back to the original. So if I rewrite the original equation, x plus 6 squared equals 49. And I want to check this now to see if I'm right. I take my first number and replace x with 1. So this would be 1 plus 6 squared. Does it equal 49? And then you're back to doing, please excuse my dear Aunt Sally. I do what's in parentheses first. 1 plus 6 is 7. 7 squared is 49. It equals 49. It checks. We also have to check this solution because there's two answers. So we do the same process. Instead of using x as 1, we're going to put in that spot negative 13. Negative 13 plus 6 is negative 7. Negative 7 squared means a negative times a negative, which is positive 49. It checks. If your solutions do not check, it means you made a boo-boo somewhere working it out, and go back and try it again. Every time you solve a quadratic and get two solutions, they both should check in the original. Now, let's look at one more on the notes. Let's look at example 6. It looks very simple, but it's tricky. So on the notes, example 6, quadratic equation is x squared plus 9 equals 0. Okay, is it an equation? Yes, it has an equals. Is it quadratic? Yes, it has a square. How do you solve it? Well, let's talk. If it's already set equal to 0, what about factoring? Well, does it fit the three rules? Is there a GCF? No, there's not. Is it a difference of perfect squares? No. That's a plus, that's a sum, and we've already discussed way back when that the sum of perfect squares can never factor into two parentheses. And it's not a trinomial, it's not three parts. So we can't use factoring here. But we'll use our new method. We'll do the square root method. Move the constant to the right. Can we move somebody? Sure, we can move the 9 by subtracting it. So we get x squared equals 0 minus 9 is negative 9. Now we should square root both sides. So we're going to square root the left. We're going to square root the right. Squares and square roots are opposites, inverses, so they cancel out. Just like your add 9 and subtract 9 were opposites, inverses, they cancel out. That'll leave us x. Don't forget on the right side to put your plus or minus to show two answers. And now we have a square root of a negative 9. All right, so the last step is to reduce the root. Sweeties, think back. These are facts now. Square root means a number times itself. Is there a number times itself that will give you negative 9? 3 times 3 is positive 9. Negative 3 times negative 3 is positive 9. There is no same number you can multiply to make a negative 9. So we can't finish working this. We cannot do this operation. So if we can't finish working it, that means we can't have an answer for x. In algebra, when you are solving an equation and you do not have an answer for x, because we got to stop here. We can't do anything more. This we can't work it. It doesn't exist. When you're working an equation and you don't have an answer, this is when you use the famous phrase, no solution. Solution means answer. I have no answer. I cannot work this to get a number. Remember, if you type square root of -9 in your calculator, it gives you an error because it can't be done. The symbol for no solution is a 0 or a letter O with a slash. That is why in math and algebra, you cannot write this and say it's a 0. I know military, they use that and they say it's a 0, but in math, this is not the number 0. This is the symbol for this phrase, no solution, which means I do not have an answer to an equation. You only use that phrase, no solution, when you're working an equation and you can't get an answer. Okay, catch you in the next module.